Hi, so today we are going to learn direction of vector product of two vectors, and secondly the magnetic field at an axial point due to a circular current carrying conductor. So we will start with finding the direction of vector product of two vectors. Let there be two vectors A and B starting from point O, origin is O, and the angle between the two vectors is theta. Then vector product of two vector A cross B is equal to, the magnitude is equal to AB sine theta. Now next thing, the direction. So if you place a screw at the joining point at the origin of the two vector, and if you rotate the screw starting from initial vector A to vector B along the smallest angle, this is your smallest angle, so you will see that motion is along clockwise direction, and when you turn any screw in clockwise direction, it tightens inside, it goes inside. So here the vector product will be going along downward direction. If downward direction is negative y-axis, so direction can be shown by minus of j cap. Now let us take second case. Okay, so here A is along this line and B is above, and now you have to find the same thing, vector product of A cross B. So you place a screw at the joining point of the two vectors which is at an angle theta. Okay, so magnitude will be given by magnitude of A into magnitude of B into sine of angle between the two. This is giving you the magnitude. Now you have to rotate the screw starting from first vector to another vector, and you will find that this rotation is done in anti-clockwise direction. So assume when you move any screw in anti-clockwise direction, it comes out. It does not go in anti-clockwise direction motion. A screw comes out, so motion will be in upward direction. In this very case, so if upward direction is y-axis, so direction can be assumed by j cap. Okay, unit vector along this direction is j cap. So magnitude associated with unit vector along that axis. So this was about screw rule. We have obtained two directions in two cases. Now there is one more rule for direction of vector product of two vectors, that is called right hand thumb rule. Right hand thumb rule. Okay, so here you have two vectors. You can see two vectors A and B, and you have to find vector product. Here you have angle between the two is theta. So direction according to right hand thumb rule of A cross B can be realized in this way. You keep all the fingers along straight way as shown in diagram along first vector. The first vector is A, you can see first vector is A. So keep all the fingers of your hand along first vector, keeping thumb at 90 degree vertically upward, and move from first vector to second vector, and you will find that your thumb is pointing along upward direction along y-axis. So in this case, vector product of two vectors is equal to, firstly we will write magnitude AB sine theta. This is magnitude, and for direction which is along positive y-axis, so you should write j cap, unit vector along y-axis. Now in next case, when we have similarly when we have a vector, another vector, not A and B, a dl vector along this direction, angle is theta in between dl and r. Therefore dl cross r will have a magnitude, product of the magnitude of the two, dl into r into sine of angle between the two. This is magnitude, and it will be associated with the direction of this vector. So as per before, you will keep your fingers straight along the first vector, here I have kept, and then you will rotate the fingers of your right hand along second vector, and you will find that thumb is pointing along positive y-axis. And unit vector along y-axis is j cap only, j cap. So this is how you will be using right hand thumb rule in the two cases. Now another case. Suppose a first vector is in upward direction along y-axis, and another vector is close to you. Now again right hand thumb rule, but here for A cross B, you will place your fingers along A. You will place your fingers along A, and then you will see that your thumb is pointing downward. Thumb is pointing downward, and then when you rotate your fingers from A to B, thumb remains downward direction. So A cross B has direction just opposite to y-axis. If it is your y-axis, so A cross B will be along minus y-axis, and this is your minus j cap. So here you will be writing magnitude AB sine theta, and then it will be associated with direction minus j cap. Now similarly, if you have another vector, in place of A you have dl vector, in place of B you have r vector, then dl cross r. In the similar way, you can write firstly its magnitude, then you will write its direction. So it is equal to dl r, and if angle between the two vectors is theta, so dl r sine theta. And for direction, keep your right hand along the fingers of your right hand such that thumb is at perpendicular direction. So keep your fingers along the first vector and rotate your fingers along second vector. You will find that thumb is pointing along a downward direction. So downward direction which is having unit vector minus j cap. So here with magnitude you will be writing unit vector. So any vector is represented by magnitude into unit vector along that direction. So this is how you will be finding direction of two vectors. Now magnetic field due to a circular current carrying loop. current is going along this direction of magnitude I and coming along this direction. Okay, so magnetic field at an axial point from origin, from the center of circular loop to a point P, which is at a distance x from the center of circular loop. Now current is coming along this direction. Let me take a small length element, dl length element. So this circular loop is perpendicular to the plane of the paper. Circular loop is perpendicular and this r vector is on the plane. So obviously the two are at 90 degree because circle is perpendicular to the plane and r is on the plane. So here you have angle between dl vector. This theta angle between dl vector and r vector is of 90 degree. So what will be value of dl cross r? Dl cross r will be equal to dl r sine 90. And also direction. This is your magnitude and I will associate with this magnitude its direction. So let me find direction using corkscrew rule. Here I have drawn a vector parallel to dl, here this vector, and another vector parallel to r, this vector, and both are, as we have discussed, both are at 90 degree. And we have to find direction of dl cross r. So when you turn the screw starting from first vector dl vector and when you will go to another vector along the smaller angle is 90 degree, out of 360 smaller is 90. So you find that your screw is going anti-clockwise direction, means it is opening, it is coming out. So dl cross r will have a direction along perpendicular to both dl and r and in upward direction. So let me find for dl cross r a vector. Okay, I'll be doing it later. So this is about dl cross r. Now let me divide the whole circular loop. In small length elements. One such element is dl. And apply Biot-Savart's law. For its magnetic field. As Biot-Savart's law is for small length elements. For this purpose, I have to divide whole circular loop into small length element, and I took one small length element dl, and then I'll find magnetic field at point P due to this dl length element. Since we know that magnetic field using Biot-Savart's law is equal to mu naught upon 4 pi I dl cross r upon rq. This you can also write as mu naught upon 4 pi I dl r sine theta And here theta is angle between DL and R, and we have obtained this is 90 degree because the length element is perpendicular to the plane. Circle is perpendicular to the plane and R vector is on the plane. So angle is 90 degree. So we obtained mu naught upon 4 pi I dl. Okay, there is one mistake. There is one mistake. No, this R should be cancelled then. Okay, now it's okay. dl upon RQ. So dB has magnitude. Here I have written only magnitude. I have not written its direction. So magnitude is this much. Let me come on diagram only. Here you have dV. Here you have dB. Because dB will be perpendicular to both the vectors dl vector and r vector. Now dl vector is already perpendicular because circle is perpendicular to the plane and dB is on the plane. So in any case dB will be perpendicular to dl. Now with r it should also be perpendicular. This angle should be 90 degree. Okay, so I have drawn one dB vector along this direction. Now when two right angles, okay, when two vectors meet at some angle theta, then their perpendiculars, perpendicular of this is here and perpendicular of this vector is here. So if two vectors are there at angle theta degree, their perpendicular should also be at the same angle theta. Now we will find component of this dB vector along horizontal direction and vertical direction. This is your dB cos theta along vertical direction and this is your dB sin theta along horizontal direction. Now each length element will have a length element just opposite to it, and for which their vertical components will be cancelling each other. So now according to figure, for each length element there is equal and opposite length elements such that they will cancel their vertical components Let us see how. So for this length element you have a length element in vertical direction dB cos theta. For a similar length element you will have a vertical component along this direction and a horizontal component bhi dB2. So dB sin theta will be added, horizontal component will be added and vertical component which are in opposite direction to each other, they will be cancelled. So what is net fill? Net fill due to dl length element is only dB sin theta. Therefore, net fill at point P due to dl, idl, okay, idl you should write current element. The source is current element only. So net field at point P due to ideal current element will be dB sin theta only. Okay. And this is along horizontal direction. You may write here unit vector of horizontal direction. As positive I cap, if you take this horizontal direction as x-axis, so net field will be dB sin theta. This is your magnitude into I cap. Okay. So from equation 1, dB net is equal to, let me put the value of dB, mu naught upon 4 pi I dl upon r square and this sin theta. This is a different, okay, here I should take a different angle. If here is, it should be phi, okay, it should be phi, and there is angle sin theta. So let me put the value of sin theta. From figure, sin theta is equal to perpendicular r upon hypotenuse, this r, capital R upon perpendicular upon hypotenuse. Okay. So in place of sin theta, I'll be writing perpendicular upon hypotenuse into I cap. Therefore, net field due to whole circular lobe can be obtained by integrating equation 1. Therefore, dB net is equal to integration of mu naught upon 4 pi I dl r upon rq. And what is r? What is this r? This hypotenuse. Since hypotenuse is equal to root under perpendicular square plus base square, and this is equal to root under r square plus base is your x square. So we will put value of r here. Therefore, B net is equal to, let me take every constant outside. Mu naught is a constant, 4 pi is a constant, I is a constant. And you know, this is your radius. Radius also is a constant. And here you remained with dl upon, in place of r you will be writing, this is your r, hypotenuse r. Therefore r cube, what is r cube? R cube is equal to r square plus x square whole power. This is under root is 1 by 2. 1 by 2 power 3. So 1 by 2 into 3. So 3 by 2. So all these are constant. R constant, you can see. For a given point, this radius of circular loop is a constant. For a given point, x is a constant. It is not going to vary. And this distance from dl length, this also is a constant. Everything is constant. X, small r and capital R. So, all such things must be out of this integration sign. It becomes equal to mu naught upon 4 pi I r upon r square plus x square whole power 3 by 2, and integration of dl. Total length element means circumference, and circumference is equal to 2 pi r only. So this is your 2 pi r. Therefore it is equal to pi cancel, mu naught upon 2 cancel, 2 to the 4, mu naught upon 2 I r square upon r square plus x square whole power 3 by 2. So this is your magnetic field at an axial point. So what is magnetic field at the center? Let me find. At the center, this distance x should be equal to 0. At center, you can say, at center for magnetic field, you need to take x 0. When x is equal to 0, then point P comes to a center. So I am just taking, when I am taking x is equal to 0. When x is equal to 0 means the point P reaches center. Therefore B is equal to mu naught upon 2 I r square upon r cube, and here you are left with r. So therefore B is equal to mu naught I by 2r. You can also write in this way, mu naught by 4 pi to I upon r, so that B can be written in term of magnetic constant, mu naught by 4 pi. So in this way, 2 pi I upon r. Okay, 2 pi I upon r. Direction of magnetic field due to a circular current carrying conductor can be obtained, in this diagram you can see, can be obtained by right hand thumb rule. Place the curl of your fingers in the direction of current. Here curl is placed and thumb is pointing in this direction. So magnetic field is in this direction only. Now in second figure, you can see that the curl of the fingers are placed in the direction of the current. Direction of current. As per right hand thumb rule, this is your right hand. So thumb is pointing the direction of magnetic field, and that is along negative x-axis, this direction. So using these two, you can find magnetic field of a straight current carrying conductor. This is magnetic field lines, and magnetic field, it is giving magnetic field at each and every point. Here magnetic field is in upward direction as per right hand thumb rule.